Hello and welcome to another tutorial. We're going to continue our discussion on more on classes in Java, and now we're going to look at the topic of understanding class members, which we've already seen that. We've seen that a class has a state which is associated with the class itself, and that's the static part of the state. And then members or objects of that class. Again, when we say class here, you replace it with the keyword type, because type, as I mentioned it many times before, is a more generalized version of class. Here type means it can be an interface. An interface can also inherit from another interface, enums for example, etc. right? So but for now, again, the focus is mainly on classes. That's just because classes are where the actual action happens. Usually interfaces are just abstract stuff, so you can't do much with the interface itself. You can never call the new operator on an interface. We will look at anonymous classes that don't have a name, and you see that how they actually allow to call the new operator on interfaces. But the key here is that even with interfaces, you have to understand that when you call a new operator on an interface and create an in-place implementation of the abstract method in the interface, you're not instantiating the interface. You can never instantiate or call the new operator on an abstract entity like interface. But you can create anonymous classes, classes that don't have a name at compile time, but at runtime JVM just comes up with some name and then instantiate a class that implements that interface, right? Just be careful about that. So classes have a state. A state has two parts. One is a static part, which is not associated with a particular instance of that class. It just associated with the class itself. All the objects or the instances that you make from the class share the same static state. And then if any one of the instances changes the static state, that change is immediately visible for the other objects as well, right? Now the other part of the state is non-static state, and every instance or every object of the class gets its own copy of the non-static state, and they don't share non-static state with each other. So if there is a field called, for example, int x in a class definition, each object gets its own copy of this variable, which means the memory locations are separate for separate instances. Whereas we saw that for the static state, there's only one copy of a static variable, a static field, and that's actually not created when you call the new operator, right? When you call the new operator on a constructor, it means you are creating an instance. So you just want to allocate memory for the non-static part of the state and initialize that memory with whatever parameters you pass to the constructor, right? So a static state is created in the memory when the JVM actually loads the class file. When the JVM loads the class file, it wants to understand the properties of the type of the class itself, right? And JVM sees that you have some static fields, and so it goes ahead and loads the class into memory, allocates some memory in the Java heap, and then creates those variables that are the static fields of the class, and then initialize them with whatever value you've initialized them. We saw that one special case of a static state are compile time constants, which are normally defined as public static final. So if it's final, it has to be initialized and it can never be changed. If it's a static, you cannot if it's final and static, you cannot initialize it in a constructor, because now it's a static. It doesn't have to be waiting for you to create an instance or an object of that class. So any field that is a static final, it has to be initialized as soon as you define it, exactly in the same line of code. And we saw that in the previous example when we looked at for example, the compile time constants. So a static final fields, and they're typically public so that everybody can access them. Nobody can change them because it's final, and then nobody needs to call for example, a new operator, because a static means you don't have to create an instance of object to access that field. And again, for the compile time constants, the premise or the assumption is that if somebody wants to access that compile time constant, they have to be able to access the type first, because we said that there is usually compile time constants are in the global scope of your program. But in Java, there is no such thing as global scope. Every variable has to be inside the scope of a class. And we saw that there is a distinction between being able to accessing a type and or accessing its state or constructor or basically methods. So accessing the type means either a type is public or package private or package level access. So if other classes or other interfaces, for example, in another package want to access this compile time constant, even if the field is public static final, even if the field is public, if the type itself that this constant is defined inside of it, it's not public, then other classes may not be able to access them. So this usually creates a kind of a restriction, and the solution is usually what we do, we create a util package. In our program, we create a util or utils or utility, something like that. And then we create a class called constants, right? Usually, if you look at a Java library for scientific computing, you see there's always a util and then there is a constants there. And then usually the constants class only holds, like, let's say scientific constants, right? And these are all compile time constants. And what this means is that these are just variables that hold numbers. At compile time, the compiler replaces the variable with the actual number. For example, public static final, again compile time constant, public static final. And know that the class is also public, so we want everybody, even in other packages, access them. And usually all types or classes in the utils pack, in the util or utils or utility, these are the namings that we usually use. Utility package are public because these are utils. Other packages are supposed the types or classes in the util package usually are classes that provide helper methods, helper functions, and normally all of them are static, right? And then the whole idea is that we group all of these helper functions, methods, in a package and then make them public, so that other classes in any other package in the project can access them. So pi 3.1415, something like that. This is a compile time constant, and obviously we have to give it a type. Let's call it double. And then public static final int I don't know, basically or maybe we can define another constant. There are many constants like double, electron charge, for example. If you also recall, I mentioned that the convention is that all letters have to be caps, and you separate different syllables with underscore. Electron charge, for example, is basically 1.62 E minus 19, something like that, right? And again, if you look at any scientific library in Java, for example, you see that there's always a class called constants or physical constants, maybe, or maybe you want to separate physical constants, physics constants with chemistry constants, with math constants, etc., right? Now, obviously, the example, one of the clear examples is math class in Java. So if we try to open up a math class, let's say from JDK 17, and most of the classes in JDK classes, most of the classes in the JDK itself, they also define constants. Public static final double pi is this, e this is the natural number is this one, and these are public static final. And note that this class math has to be public so that everybody else can access these constants, even though these are constants and public. Remember, a field can have its own access modifier. But if somebody doesn't have access to the type itself, if the type was package private, I can never access this public field outside the package that the math class is in, right? It's in the Java lang. So people have to have access to the class itself, but it doesn't mean that people can instantiate the math class, because the constructor is private. So you can never, nobody else can call the new operator on this constructor because it's private. Private means you can only use this constructor as long as you are physically in the scope of the class. As soon as you go out of the scope of the class in another class, for example, you can never use this private constructor, right? So you can never instantiate the math class, and math class is an example of the utility class. All the methods in the math class are, or even the fields, everything in the math class is static and public. So again, utility classes are typically all public, all the fields are public, all the methods are public, and everything is static because utility classes usually don't provide any state, right? They just want to provide helper methods, helper functions, or some constants so other people, other classes can use them. So math class is a very nice example. Java.lang.math is a nice example of a utility class. So everything, all members, all fields are public static, and then all methods are public static. Now obviously sometimes you want to break a long method into a smaller ones, that's why, or some other helper or helper fields. That's why you see there is also some private constants, and these are used in some of the methods. For example, degrees to radians. This is, for example, here 2 radians. This is a public static method that takes a angle degree and converts it to radians. So again, these are you see some private fields or maybe methods there, but those are used in some of the public API that this utility class provides. And again, for the utility classes, we make the constructor private. So private constants, and then this prevents others. This prevents others to instantiate this class, because this class, utility classes, don't hold a state. Utility classes don't have let's say non-static state. It doesn't make sense for them. They're supposed to just provide some static field constants or some static helper methods, like public static let's say double let's say helper method, and let's say return something 1.1. And the final property of the utility classes is that you don't want anybody to change the implementation of these functions, because that could mess up some other functions. That's why you mark this as final. Final on a type. If a type is final, it means it can never be inherited from. It cannot be extended, right? Extended. So final means so public means everybody can access this type, and therefore everybody can access its public members, either a field or a method. Final means nobody can inherit from this, because if somebody inherits it, then they can override these methods. So because you can even override a static method, right? And then obviously another way is that maybe sometimes the constants are final. So regardless of whether the class is final or not, nobody can change these because these are final. But this method is not final. We can explicitly mark it as final, and this also works. So if you have a if there are methods inside this class, utility class, that you think people can override and then change them, then you shouldn't mark the class as final, but you can make a specific method as final. But the convention is a utility methods, utility classes are typically marked as final. Okay. All right, so in this section, we discussed the use of a static keyboard to create fields and methods that belong to a class rather than to an instance of the class. Class variables. When a number of objects are created from the same class blueprint, they each have their own distinct copies of instance variables, right? When you call the new operator on a constructor, basically whenever you call a constructor, it means you are creating an instance of that object, which means you want to allocate some memory in the heap, Java heap, and initialize the state of that particular object, right? You are only concerned with that particular object. Every object that you create gets its own amount of memory in the Java heap. That's the job of new operator. In the case of the bicycle class, the instance variables are cadence, gear, and speed. Note that we're saying that instance variables, which means non-static fields. Each bicycle object has its own values for these variables, and they don't share these variables with each other. Each one gets its own separate memory area for holding values for these variables, stored in different memory locations. Sometimes you want to have variables that are common to all objects, and not only common but also is shared amongst all of them, and everybody sees the same variable, sees the same memory location. So if somebody changes one of those variables, others see that. This is accomplished with the static modifier. Fields that have the static modifier in their declaration are called static fields or class variables. They are associated with the class rather than with any object. Every instance of the class shares a class variable which is in one fixed location in the memory, and memory allocation and initialization happens when the JVM actually loads the class file into the memory before calling any new operator or anything. As soon as JVM loads the class file into memory, if it sees there is any static fields in your class, then it goes ahead and allocates some memory and initializes those fields. Any object can change the value of a class variable, but class variables can also be manipulated without creating an instance of the class. And we saw that JVM obviously or Eclipse IDE gives us a warning if you try to use a reference to an instance of a class to change or to access static fields, because it says that, hey, a static field, just use the name of the type itself. And again, whenever we say the name of the type, it means the fully qualified name. For example, suppose you want to create a number of bicycle objects and assign each a serial number beginning with 1 for the first object. This ID number is unique to each object and is therefore an instance variable, right? ID belongs to the non-static state of each particular object, and they're not supposed to share with each other. Each one has to have its own property. At the same time, you need a field to keep track how many bicycle objects have been created. So one of the main use cases of a static state or static fields is, for example, reference counting, to keep track of how many objects of a particular type we've created at any moment. You can have a static field that is normally called count, and then the count can, as soon as somebody calls a constructor, in the constructor we saw that we can access static fields, because a static state is still part of the state of each individual object, but it's shared amongst all of them, so that you know what ID to assign to the next one. Such a field is not related to any individual object but to the class as a whole. For this, you need a class variable number of bicycles as follows. So we have a private static int number of bicycles, and we initialize it immediately to 0. Now this 0 is not necessary because it's a field. We know that when JVM loads the class, it initializes all the fields to 0, all the fields to default value. For int, the default value is 0, so this one is this equal to 0. This initialization is not necessary unless you want to initialize it to something else. If, for example, you wanted to initialize it to 1, you have to explicitly write equal to 1. But if you want this field to be initialized to its default value, which is 0 integer, you don't need to write equal 0. JVM will do it for you. But it's always the best practice to be as explicit as possible in your source code. Class variables are referenced by the class name itself, and this is not mandatory. If you use a reference of a particular object to access class variables or static fields, your code will compile, but the compiler gives you a warning. This makes it clear that they are class variables. Note, you can also refer to static fields with an object reference, like my bike. So let's say you call the constructor, use the new operator, and the new operator returns back a reference called my bike to you, and then you can say my bike dot number of bicycles. But this is discouraged because it does not make it clear that they are class variables. So I hope you enjoyed this lecture. We will continue and finish this topic in the next one, so please stay tuned, and I'll see you in the next one.